Can't wait to learn about chemistry. Yeah.
Oh, I was right. Well,
Christopher, Angel, Shenza, Achilles, Caden, Maddie, Morgan, Faith, Michaela, Ariana, yep, Jasmine, yep, Stephen, dead, Irving, yes, Phoebe and Josie, Joshua, Ben, Keanu and Pierce, Olivia, Jack, Jaden. Where's Jaden? Sorry, there you go. Okay. Eric, Josh, good, excellent, wonderful.
Yeah.
All right. So before we go and take a look at our packet, if you could change one thing about school, and no, canceling it, taking it off of your plate is not an option. What would be the one thing you would change, ladies and gentlemen?
Oh, I paid the bucks.
So we would rather have like our like summer break when winter is happening, and then have school during the summer.
Are you insane?
It's cold. I don't want to be here.
I don't want to go outside.
I don't want to go outside.
So you would rather have all your time off when it's cold out and you can't do anything?
Yes.
So I can stay home.
You two don't get a vote anymore in the changing what we're doing at school. Josh.
having school 1 day a week.
1 day a week. You want to go 24 hours that whole day though?
No, just have extended classes. So like my first 3 periods are first week, other 2 are second week. And have like 3-hour periods.
So then you also want to go all year round. Well, you can't. We got to be somewhat realistic here. You still have to get your hours in. So 1 day a week, you would never get enough schooling in. Okay? But, okay, I'll take it because I asked what could you change, and it's better than their idea back there. Achilles.
Longer lunch.
What?
Longer lunch.
Longer lunch. You need more time to eat.
Yeah,
It is.
that's valid.
Okay, and they could do that, but then you're going to be here a longer time during the day. So you want another 20 minutes at lunch, and you want to get out of school at 3:20. I'm just saying it is possible. They could do that. Okay, go ahead, Keanu.
Wednesdays off in exchange for just 4 days.
So you want to do 4 days a week?
Yeah. But
Okay, but why Wednesday?
teachers can plan, then it gives students that.
Whoa! If you're off, I'm off. So none of this. Well, the teachers can be here working while I'm at home. No. Because we would have to put in longer days as well. Okay. So you would rather have 2 days of school, a day off, 2 days of school, rather than like either having Monday through Thursday or Tuesday through Friday. No. Wait, that's what you just said. You want Wednesdays off.
Yeah.
Okay, all right. 4 day a week school. Okay, I can buy that. I don't even want to call on you because your last idea was so terrible.
Nap time. Oh my gosh. A nap time.
Nothing like getting you career, community, and college ready by giving you nap time. Davey,
Start later, but go later.
they have talked about doing that.
Can we please do that?
Please.
I don't get that choice, but the school board was looking at doing that, of starting the school day at like 8 or 8:30.
That's still too late.
What time do you want to start?
It's like 10 or 11.
Then you're going to be going till like 6 o'clock at night.
That's okay. It's fun to start.
Okay, you two are not allowed to suggest anything anymore. Gosh.
There should be like a technical high school, which is all electives. Like if you want to for a career.
A technical high school with all electives around the thing you want to do for a career. Okay, can I ask, when you were a freshman, you knew what you wanted to do? What do you want to do?
Medical stuff, doctors.
Okay, all right. That first reasonable idea that's come from this side of the room. Good job. Good job.
I'll take the credit for that.
Anyone else? Got any major changes that you'd like to see? Again, 4 days a week, that is not a bad idea. I think there are some places that have thought about doing that. Are you guys happy with starting next school year in August?
No.
Apparently you're not paying attention, huh?
For the draft.
But we end in May though.
No,
No.
no. That way we can not have school during the NFL draft. During the 3 days or whatever of the NFL draft. The school district is filing for a waiver to start the last week of August instead of after the Labor Day weekend. Yes. Taking all of deer season off.
Yep. Yep.
Okay? See, I'm just crazy. I just have this one little change that I would like to make. I think our school year should start after Labor Day and be done before Memorial Day.
Notre Dame does that.
And get rid of some of the days off and things during the year so that we can get it done.
Notre Dame is on the 23rd of May.
Yep, to me, that would be nice. Anybody else have any great ideas? I know I'm not looking over at Phoebe and at Josie. Yeah,
The trimesters, just do semesters.
so you want to go back to having 8 classes a day? Semesters?
To like 3 different times.
Semesters actually.
Semester, I will tell you, semesters is not that bad, but what we have heard, ladies and gentlemen, is that all the high schools and middle schools will be on trimesters in 2 years. So you will no longer be alone on trimesters. So, there are other ones, there in the, I don't know about in the area, but there are other schools that still do trimesters.
Yeah.
The advantages of trimesters, I don't know if they outweigh some of the bad things. Here's the one thing I will tell you that I don't like about trimesters as a chemistry teacher. Like last unit, we threw a bunch of stuff at you, and there's really not a lot of time to process things. It's kind of, okay, here's a topic, now here's another topic, now here's another topic, and you've really got to put in some time on things, and you don't have that with trimesters, unfortunately. Okay? Some- What?
Is it gonna be like that this time?
Oh, yeah. Yeah.
Okay.
Yeah. Definitely. Okay? Again, it's been, I have not, this is the first time I have taught chemistry in the trimester setting. So we're figuring out as we go. Today, ladies and gentlemen, we are going to do a lab, and the title on it is wrong there. It's going to be Mass versus Mole Lab. So before we get to that, though, take out your packet, ladies and gentlemen, and I want to go through a couple of things real quick on your packet because some of you suck at naming still. I'm just going to be very honest with you, okay? Just going to be very honest with you. Some of you are struggling with naming, and because of that, ladies and gentlemen, we need to make sure we do this before we go on. All right. Second page. Ammonium chromate.
Oh, you're right. Oh.
All right, so ammonium chromate, the formula. NH4.
Can't see it. Thank you.
Open your eyes. NH4 in parentheses 2. CrO4. Now, please remember the 2 distributes out to everything inside, both the nitrogen and the hydrogen. So when you're counting up how many nitrogens here, you've got 2, you've got 8 hydrogens, you've got 1 chromium, and you've got 4 oxygens. If you can't do that, ladies and gentlemen, you are going to struggle with the rest of the process. Magnesium chloride. What does chloride mean? It is on the back. And what does the ITE ending mean? Because you won't find it on the back. You've lost 1 oxygen. Okay? It is on the back, but it's on that side. Magnesium plus 2. Chloride, ClO2, and it is a -1, so I need 2 of them to balance off the magnesium. Questions? Iron 3 oxide, ladies and gentlemen. That is a simple binary ionic compound. Fe has a +3 charge. Oxygen has a -2 charge, so Fe2O3 would be your compound there, ladies and gentlemen. Questions? Aluminum hydroxide, ladies and gentlemen. Aluminum is Al. It is a +3. Hydroxide is OH. It is a -1. So AlOH in parentheses 3. Questions? Barium phosphate. Barium, Ba +2. Phosphate, PO4 -3. So Ba3, PO4 in parentheses 2. Questions? Manganese 4 chloride. Manganese, Mn. The 4 means that it is a +4 charge. Chlorine is a -1. So MnCl4. Questions? One left on the back side, ladies and gentlemen. Copper acetate, copper 2. Cu, which is a +2. Acetate, C2H3O2 is a -1, so there have to be 2 of them, so they have to be in parentheses, ladies and gentlemen. Questions? Again, to find a correct formula mass, ladies and gentlemen, you need to have a correct formula. When you have a correct formula, finding the correct formula mass is not that difficult. Does anyone need these still? So for this one, how many copper in this compound right here, ladies and gentlemen? 1 copper. How many carbons in this one?
4.
4. The 2 outside distributes to the 2 inside. There are 4 carbon. How many hydrogens? 6. How many oxygens? 4. Copper, 1 times, what's the formula mass of copper? 63.55. 4 carbons times 12.01. 6 hydrogens times 1.01. And 4 oxygens times 16.0. If you do it long enough, ladies and gentlemen, you will get to know these. Oxygen is very common. It will become easier as you do more and more of these. If you don't ever practice them, though, you won't ever memorize them. Okay? And who knows, maybe you won't ever memorize them anyway, but you just got to be able to find them on the periodic table. So 63.55 plus 48.04 plus 6.06 plus 64.0. What do we get out of that, ladies and gentlemen? $181.65. What's the unit? Grams per mole. That is the unit, ladies and gentlemen. Questions? Now, this is the basis for what we're going to do next, which is use this to convert from a certain amount of grams you have into moles, or a certain amount of moles you have into grams. But again, you've got to be able to do this. This is the only one that you need to calculate. If we go from volume of a gas to moles, we use 22.4. If we go from particles into moles, we use 6.02 times 10 to the 23rd. This is the only one that changes because it depends on what the mass of the compound is. Okay? Questions? All right, so let's take a look at the lab that we are doing today, ladies and gentlemen. Go into the Google Classroom site. You can either get there from this front page where it says mass versus mole mini lab, or you can go inside and do the mass versus mole lab. Open it up, ladies and gentlemen, and let's take a look at it. Okay? The lab is worth 29 points, ladies and gentlemen. Okay? The purpose of the lab, ladies and gentlemen, the purpose is to study the difference between the mole, let's change that, the use of the mole versus the use of mass when measuring a substance. I'll make that bigger for you to read a little bit easier, ladies and gentlemen. But that is what we are doing. We're trying to see the difference between looking at measuring mole. What is mole? Okay, but what is it? What does it describe? For example, meter describes length. Kelvin describes temperature. What does mole describe? The quantity, the amount of substance that is there. Now, a mole is an incredibly large amount. We are not going to be working with a mole of something in the lab. But a mole is when you have a certain amount of something, okay? So, for example, if you buy eggs, you buy them by the dozen. If you buy golf balls, you buy them by the dozen. If you buy pencils, you buy them by the 10-pack. There is a certain amount that is there, ladies and gentlemen, and that is how they sell them. The other way we sell things is if you go to the deli counter at your local grocery store, normally, could be wrong, but normally people ask for a half a pound of ham or a pound of ham. Some people do ask, I want 7 slices of cheese. Okay, go for it. You're buying it by the amount then. Most people go and buy it by the mass. I want a half a pound, I want a pound, I want a quarter pound, whatever it is. And you get a certain amount because of that. Okay? That is what we are going to be looking at in our lab today, okay? Everything is set up in the back of the room for you. You are going to have to move around from station to station, though, ladies and gentlemen, because there are 6 different stations set up back there, okay? And at each station, you are going to have to do 2 things. So let's talk about this, okay? First of all, as always, you will make qualitative observations of things. So there are 6 stations set up in the back of the room, ladies and gentlemen, and they are all labeled for you. At each station, there is a container with the object loose in it. So right here is the paperclip station. There is a container that has all kinds of paper clips loose in it, one with a bag. Do not take anything out of the bag. Do not put anything into the bag. Otherwise, you are going to ruin the lab. Okay? You have weighing bolts here, ladies and gentlemen. Multiple weighing bolts. You need to find the mass of 50 paper clips. 50 of them. Every station you go to, you're going to find the mass of 50 of the objects out of the tray of the loose objects. You are also going to find the mass of the bag full of objects. That is what you have to get done, and you also need to make observations of these. Qualitative observations, what you see, what you feel. Hopefully you don't hear anything. You can smell them, don't taste them. Do not lick them. 3 observations minimum. Now, here's the other thing, okay? There are multiple weighing bolts at your station. The worst thing that you can do for the group that is working across from you is tie up the balance by taking and putting your weighing boat on there. We don't need to throw that away. And zeroing it out and then going and counting your sample out, because now they can't use this balance. So get your sample counted out, put your weighing boat on there, zero it, put your 50 in there, put it back on there and take the mass. You want to do that, that is absolutely fine. Okay? But don't be surprised if someone else comes out and zeroes it while you're working if you zero it and then go back. So you always have to zero this because we only want the mass of the 50 paper clips. You want to use the 2 trays somehow? I don't care, but you need to find the mass of just the 50 paper clips. Okay? And you need to make 3 to 4 observations of them. At this station, there are marbles. Again, the bag of marbles don't open up. There are loose marbles in the tray. Now, I will tell you, I don't think there are enough marbles here for 2 groups to work at this station at the same time. Okay? But we also gave you the larger trays here because you will need them. Back here is the nut station. There are metal nuts back here, ladies and gentlemen. Again, a loose tray full and a bag full. Observations, 50 of them in a weighing boat, and the mass of the bag. I'll show you where to put those masses in a minute. Back here are thumbtacks, bag of them, and an empty container of them. Over here, ladies and gentlemen, are nails. And over here are the washers. Again, plenty of weighing boats. If you need more, ladies and gentlemen, there are extras right here. You can come and you can grab and you can use. Now, you need to get all of your information collected today. You should be able to get everything else done today, but you need to get at least your information collected today. So up on the top part up here, ladies and gentlemen, that is where you will make your observations. Okay? Observations. Then, down here, ladies and gentlemen, in the next table, here is where you are going to find the mass of 50 of your sample. Okay? Just the mass of the 50 pieces. Now, how do we then find an average mass here? What? Divide what by 50? This is why we only want the mass of the objects, not the mass of your weighing boat. To find the average mass of an object, we need the mass of 50 of them, and then we divide by 50. That will give you the average mass of one of your samples, and you're going to need that in a minute. Okay? So you do the 50 paper clips in the tray, you find the mass of just the paper clips, divide it by 50, you get your average mass here. Questions? Now, here in the calculations table is where you will find the mass of the large bag of sample. So the bag that is sealed up, the bag that is ready to go, you find the mass here. Now, very careful. When you are putting that into your balance, make sure that it is not touching the sides of the glass inside. Make sure that it is not falling off of the pan and touching the bottom. Otherwise, you are not getting an accurate mass. So you need to make sure that your bag is in there and it is sitting on the pan of the balance and it is not overhanging or touching any sides in there. Okay? You need to close the doors of it so that you get the most accurate mass. Now, because it's already in a bag, I have pre-massed out the bags. So you're going to have the mass of the sample and the bag here. Here's the mass of the bag. If you subtract these two, you will get the mass of the sample alone. Okay? And then what your job is to take the average mass that you got in the last table. Put that number in here so that you can take the mass of just the samples in the bag divided by the mass of one piece of the sample and figure out how many pieces are in the bag. Figure out how many pieces are in that bag. Now, what kind of number does this have to be?
A whole number.
Thank you. This number has to be a whole number. There is not 0.72 of a paper clip in that bag. There is not 0.81 of a thumbtack in there. So this number down here has nothing to do with sig figs. It has to be a whole number because we know that there has to be a whole number of the sample in the bag. Okay? So, take the mass of them, do your subtraction. This you get from the table up above where you found the average of each one of these. And then tell me how many pieces are in the sample. Okay? There are questions down below, ladies and gentlemen. Some of the large samples had the same mass without the bag, or at least very close. Now our balances read to the thousandth of a gram. Even if you're off by a half a gram, you will find 3 of the masses in this table to be very close. The masses of the sample alone. You'll find 3 of them to be very close. So you tell me which samples those were in that question. The question below it. Some of the large samples had the same amount of sample in each of the bags or very close. So which of the samples? So in here I'm looking for things like paper clips, marbles, thumbtacks, nails, washers, nuts. Those are the samples. Those are what goes into these boxes. Questions? What are the 2 ways we measure things out in this activity? Shouldn't be difficult for you. What was the same and what was different about the 3 samples in question 1? So in question 1, give me something that was the same and something that was different. Question number 5, what was the same and what was different about the 3 samples in question 2? That's it. That's your lab. When you're done with that, you can go back to your seat. You can work on your worksheets some more. Okay? Again, each side of the lab station is a group. Groups of 2, ladies and gentlemen. Let's go. Let's get to work. The mass of the sample and the bag minus the mass of the bag will give you the mass of the sample. When it says the average mass of one piece of the sample, that's what you found in the table above where you took 50 of them, their mass of 50, and divided it by 50. Now, why do we take a sample size of 50? What? That's more than enough. Yeah, if we just take one, who says that every paper clip in there is exactly the same size? Who said every thumbtack was exactly the same size? Now, they should be close. But again, by taking a larger sample, a sample of 50 of them, we've got a larger amount. When you take the average of a larger number, it should be better. Okay? It's like asking 2 students, would you like to have school in summer and not winter? You may get 100% of students that want that. But if we did that amongst the whole class, that percentage might change. I'm just kidding with you. Your idea is your idea. You're entitled to it no matter how terrible it is. Okay? So, but anyway, when you get this mass alone divided by the mass of one of the sample, that's from the table up above, and that will give you the number of pieces. Now again, this number is probably going to come out to be a decimal for you, but we know it can't be because I counted how many were in each one of those. I didn't count to 163.875 of a paper clip. Okay? I understand it may not come out to a whole number, but it has to be a whole number. Have a great day, ladies and gentlemen. We'll see you tomorrow.